Good, 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 good. If I could, well, I can dance a little bit. I'll do a happy dance for you with the gray white looking heart. Thank you so much for letting me know that. I appreciate that. Okay, so I'm going live now on on YouTube. So for those of you all that need extra help, you got me over here now. And I'm pulling up my stuff now so that you all can actually see some questions. But that is good news, good news, good news. I love to hear it. I love to hear it. So to start you guys off, I know many of you all are excited about this semester, but what if this is your what if this is the email that you get from your professor that says you passed your final chemistry exam? Wouldn't you be so happy? Wouldn't you be so happy? I know you would be. Because so many students are going through a lot right now. So many students. And, and I feel bad because I know there's a lot of information to retain. And I'm not trying to be that professor that says, you know what, it is what it is. No, I know there's a lot of information to retain. However, if you put in the work the entire semester, listen, guys, you should do fine. But I know some of you all may have test anxiety. My laptop is it's a little dusty. I know some of you all probably suffer from test anxiety, but what strategies have you used to retain the information? What strategies have you used to retain the information? So, and now at this particular point, some of you all need to pass your final exam in order for you to get out of that class to move on to your next level. And I get it. I totally get it. So I'm going to go ahead and get you guys started with this final exam review. And I know too that you guys are going to be in for a treat, but let me also hear this too. For those of you all that are in here right now, if you can, do me a favor, tell me what other subjects you want me to go over today. I know Isabella said she wanted Henry's Law. Okay. So I want to make sure that I go over things that are beneficial, for students that are actually in the building. So in other words, if you are here for General Chem 1, I did a lot of that last week. But if you're here for General Chem 2, I wanted to at least dedicate the next couple of days for you guys. So if you can, in the comments box, okay, Haley said ideal gas law. Okay. All right. I want to do what matters. I want to do what makes sense. Equilibrium, Candace said equilibrium. All right, let me write this down because I don't want to forget. I really do want to help you guys on all the topics. So I have Henry's Law, ideal gas law, equilibrium. So Candace, are you talking about this right here? Because I do have some equilibrium problems that deals with the ice chart. So is this what you're talking about right here? Identify the correct equilibrium expression, stuff like that. Let me zoom in. Is that what you're talking? Okay, got you. Well, I got you on that. Okay. Anybody else? Any other topic you want me to go over before we get started? Okay. So Candace wants equilibrium. So what I'm going to do is actually start there. Since I already have it up on my screen, I'm going to actually start here. Okay. And then I'll go through Henry's Law and ideal gas law. Okay. So first off, when it comes to doing these types of problems here, you've got to first identify what you know in terms of equilibrium expressions, okay? And if you know what you know about equilibrium expressions, then you're able to address the concerns that you have when it comes to equilibrium problems. So one of the things that I do with students when it comes to this part is I give them certain tips and tricks to help them remember certain things. So for this particular problem, it says for number 4, it says identify the correct expression for the following reaction. So I'm gonna zoom in a little bit because you really don't care about the answer choices right now anyway. We just really need to look at the problem itself. So what you've got is carbon dioxide reacting with water to form, or it's in equilibrium of glucose and oxygen. So here's the deal with this particular problem. If you remember, the formula for equilibrium, in order to find equilibrium expressions, you've got to have KEQ equals the products divided by the reactants, okay? Products over reactants, okay? So now here's the other thing too. You've got to also make sure that whatever the products are, if there are coefficients there, you raise it to that particular power, okay? Now, notice the physical states also. Notice the physical states. There are gases, liquids, solids. There are 3 physical states here. But what do you have to remember when it comes to your equilibrium constants? You do not include solids nor liquids, okay? You do not include solids nor liquids. So in this particular expression right here, we're only going to have the oxygen, which is O2, raised to the power of 6 over carbon dioxide, raised to the power of 6, okay? And then that way, you're able to address your final answer. So if you know that the equilibrium concentrations formula is products over reactants, that means you get rid of solids and liquids. They're not included, okay? Only your gases. So it's the gas, oxygen, raised to the coefficient's power over carbon dioxide raised to the coefficient's power. So if we take a look at these answers here, which one would the answer be? Oxygen raised to the power of 6 divided by carbon dioxide raised to the power of 6. Okay, put your answer in the chat. Since we just went through this particular problem, put your letter in the chat. And while you do that, I'm going to grab my water. I'm on this thing of drinking a gallon of water a day. Okay. I got my spring water here. Okay, guys, here, go ahead and put your answer in the box. Okay, put your or in the chat box so we will know. Okay, are y'all nervous? Are you nervous? Let me help you guys out. Oxygen over carbon dioxide, both of them are raised to the power of 6. So which answer are you going to pick? It should be letter C. Letter C, okay? Letter C. Oh, okay. Gotcha, Candace. Gotcha. Oh, I remember those days. Sweet babies. I remember them. Okay. So what I was saying, Candace, I'll redo it for you, honey. I'll redo it. So for this particular problem, we were looking at the equilibrium expression, and we know that the equilibrium expression is products over reactants, and that we cannot include solids or liquids. So we're only looking at the gases. And in this case, the products is on the right-hand side, the reactants on the left-hand side. So we have oxygen over carbon dioxide, and they're both raised to their coefficient power. So in this case, for oxygen, it's going to be raised to the power of 6, and for carbon dioxide, the same thing. So the answer is letter C. And I'll zoom in so you can see that. It's letter C. Matter of fact, let me go ahead and circle that one. Okay. I'll put a little star by it. Okay. Now, this next one for number 5, it says the value of Kc for the following reaction is 2 times 10 to the negative 10th power at 100 degrees Celsius. Okay, so in other words, what you see right here, okay, this right here is the equilibrium or the formula or the reaction rather, excuse me. This is your reaction right here. This is the Kc. Now, notice that it flipped though, right here. It flips. So what we want to know is, what is the value of Kc? So if the Kc for this reaction right here is 2 times 10 to the negative 10th power, what is it going to be when you actually flip it? So let's figure this one out. Let's go ahead and solve this equation. Whenever you're doing a problem where it's reversed, you're going to say the Kr is equal to 1 over Kc. So in this case, you're going to say 1 divided by 2 times 10 to the negative 10th power. And all you have to do now is plug this into your calculator. So I'm going to actually show you all how I plug it in also. So that's 1. Well, let me turn it on. 1 divided by 2 times 10 to the negative 10th power. And I get this big number, right? Well, the one that comes close to it, and for those of you all that are on YouTube, you can't see my calculator, but the answer is letter B. It's letter B. It's 5 times 10 to the 9th power. 5 times 10 to the 9th power. Okay. We're going to mosey on down to the next problem until you guys stop me and say you have other concerns, okay? So let's take a look at number 6 now. Number 6. Let me zoom out a little so you all can see that, okay? And I want you guys to go ahead and take a look at it. Let me scroll the screen up a little. And I want you all to take a look at that one, okay? And it says, at equilibrium, the concentrations of hydrogen, iodine, and HI were found to be 0.15 molarity, 0.33 molarity, and 0.55 molarity, respectively. What is the Kc for this reaction? All right, so let's go ahead and show you all again how to set this up. Your Kc, again, is equal to the products raised to their respective powers for the coefficients divided by the reactants. So in this case, my product is HI. And notice that there's a coefficient there. So I'm going to raise it to that power, which is 2. Divided by, I've got H2 and I2. And there aren't any coefficients there. One thing I also need to point out too is that when you guys are doing problems like this, you want to make sure that the equation is already balanced. Most of your professors may help you out by balancing the problem, which in this case, it is already balanced. So that's a good thing, okay? Now, what you're going to have to do is just plug in those numbers, all right? So HI, in this case, in our problem, was 0.55 square. Divided by H2 is 0.15 times 0.33. Okay. So if you have your handy dandy calculator, you all can plug that in too. Okay? You can plug it in also. So 0.55 squared, that top number, I'm going to put it over here on this side so I can have some space, okay? So the top number is Kc is equal to 0.3025. Now, I need to divide that by the bottom number. So 0.15 times 0.33. Those two numbers together, when I multiply them, is 0.0495. So go ahead and divide those two numbers right there. 0.3025 divided by 0.0495, and I get 6.1. 6.1. So letter D is our correct answer, okay? Letter D. Any questions so far from anybody? Anybody? Okay, so just take a look. Okay. All right. Good, good. Now, for the next problem, okay? For the next problem. Hello, everybody that just stepped in the building. We are going over some General Chem 2 problems, as I know several students are having trouble with their classes. This is the final exam week for many students all across the country. And they are trying to get those last minute tips and tricks to help them excel on that final exam. All right. Now, if you all want me to do number 7, you got to tap that screen. I need to get it up at least to 1,000. So we just need like what, 360 more hearts in order for me to do number 7. All right. So if y'all want to do number 7, tap that screen, tap, 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 so that I can make sure you all really do want me to do number 7. Okay. Because I'm trying to make sure that you guys are excelling and passing your chemistry exams. And make sure you share also. Share this out with everyone. If you have people that are taking chemistry right now, if you know people on TikTok or YouTube that are taking chemistry, make sure you all share this out with them. All right, so while I'm waiting for this, oh, I think we're getting close to 1,000. Okay. All right, keep on tapping. Oh, we're 11 away. Oh, we got it. All right, let's do it. Number 7, it says, what is the equilibrium concentration of C4H10 if the equilibrium concentrations of C2H6 and C2H4 are both 0.035? All right, let's do this problem. They gave us a Kc of 0.070. All right, so what do we need to do for this particular problem? Let's find out. Okay, so let me go ahead and get some more space because this is going to take up some space here. All right. So as you guys can see, if we know the formula, again, it's Kc, okay, or Keq equals, you can say Kc or equilibrium concentration, whichever one you like. It doesn't matter, but we'll go with Kc equals products over reactants. What do we know? Okay, so Shadul said ice table. Well, not necessarily for this particular problem. And here is why. In this problem, they're actually, that's going to be a great segue to my ice chart table. So I'm going to actually show you that one too. I'm glad you brought that up, Chadul or Chadulu. Yeah, let me go ahead and I'll stop number 7, but I'm going to show you all some reasons why you need to use an ice chart at some point. So for this particular problem, they gave us the Kc, okay, of 0.070. They gave us the concentrations for C2H6 and C2H4, but they want to know what is C4H10. Basically, you're looking for the reactants part, okay? So my formula, again, they gave us Kc equals well, actually, let me go ahead and plug this in the right way. The Kc they gave us was 0.070, okay? That's right. Hey, Aaron, how you doing? How's your semester ending? So yes, you use that Kc right there, okay? Equals, and then the products, well, they gave us C2H6 and C2H4, both of those was 0.035 times each other, okay? Divided by, well, that's the one you're looking for. Oh, no. I'm sorry, Aaron. Oh, I don't like to hear that. Oh, and haha, Shubi, no, you're going to get that 70. You're going to get above a 70 to keep you above water. Oh, all right. So let me show y'all another little trick with this problem. You can actually swap places here. Since you're needing to find X, those two can actually switch. And you can say X is equal to 0.035 times, see the top number is still not going to change, and then divided by 0.070. So what we need to do is multiply that top number, okay? So that's 0.035 times 0.035 equals 1.225 times 10 to the negative third power. Divide that by 0.070. And we get our X of 0.0175. Well, we only need two of those numbers. So we're going to round this off to 0.018 molarity. So that's why our answer is letter A. Okay, the answer is letter A. Okay. All right. All right. Okay. So now, hey, Key, what's going on? Did you get my DM or my email? Oh, thank you, user 3117. Appreciate that. Oh, yeah, I know. Chemistry, yeah. Yeah, I know y'all got a lot of stuff going on. I do. I do. It's that time of year, that energy that's going on. And although this is teacher week, I know some of y'all could care less about your teachers. The ones that actually you enjoy, make sure y'all thank them. The ones that you actually appreciated. Okay, yes, buffer equations. Yes, Shadul, you can send me a problem. Yes. And I'll try my best to answer it. So this week, I'm actually going to close out my tutoring on Thursday. So Thursday will be the last day that I do tutoring or online tutoring for until the summer. Okay. Yes, I love boba. Yes. Oh, you have a chemistry final in an hour. You got this. You got this. Okay, Key. Yes, yes. Don't give up, though. Don't give up. I don't want you to give up. Okay. Yes. So, I know so many of you all are stressed. I get it. I really do. And I wish I could give you all some comforting words because I know that some of my colleagues don't care. Okay, so yeah, Key, you know what? Well, you know what, Key, you can actually, well, and until you get to that point where you can like get into certain things, you may want to go to pharmacy tech school to even see if that's what you like to do. Because sometimes what we like and then getting into that field may be two totally different things. I thought I wanted to work in a chemistry lab. I changed real quick. Like after I graduated, I worked for a semester in a chemistry lab, and I said, I need to teach what I know. I ain't gonna be stuck in a lab. So you might want to go to a pharmacy, like do a pharmacy tech program, just so you can see if that's something that you really want to do. And go away, right? You not giving up, not gonna lie, you better not give up. No, 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 no. Now, Aaron, what do you mean your chem final is next week, but it says on Canvas it won't affect the grade? Is your teacher doing something to benefit, like to help you guys out? I would love to know that. All right. Oh, okay. Yeah. Yeah. I mean, if it's treated like another exam and it's not weighted heavier, then I can see that. What? Oh my Lord. Yeah, you know what? Yeah, I can say a whole lot about that. Yeah. Yeah, teachers got to know when most of your students are failing, there's a problem. Oh, okay. Shadulu, you can actually, oh yeah, I know about that academic, yeah, putting the professor on academic probation. Yep. Or the department being on probation. Yep, I know about that. You can always email me, Shadulu. You can go to my website and you can actually email me. Okay. So, okay, you're welcome. You're welcome. As long as it's not organic chemistry, I got you. Now, some of you all mentioned the ice chart. So let's talk about the ice chart for a minute, okay? Because with the ice chart, it is not as bad as one would think. Well, Aaron, let me ask you this. If you okay, you said, so should I talk to my professor to see if it's still possible to pass? Just one quiz and one exam, that's it. You know what I say, you always reach out. Never ever leave that stone unturned. Always reach out anyway. But at this point, like if you're still in the class and it's not like you can withdraw from it like at this late point in the lecture in the semester, but if you want to still reach out, I would. And I would say, Professor so and so, I know you're probably okay. Let me turn the camera back to me so I can tell you what to say. Okay. All right. So this is what you're gonna do, okay? Because like I'm a professor too. So when my students are reaching out to me, I love hearing from students who this is like their last push. So what I would do, I would say, dear Dr. So and so, whatever your professor's name is, right now my average is blank, and I know that there's a lot weighing on me actually passing your class. Currently, with my average being whatever it is, I want to know, not is there anything else that I can do to pass? No, don't say that. I want to know based on the final exam grade plus this quiz grade, what do you see as the potential in me actually making whatever you need to make? So like that, let's say that if you're like right at a 60, let's say 65, okay, and you need 5 more points. What have you seen in the past with students actually getting those extra 5 points on their final exam? Just looking at my grades overall. And I would rather you actually go and talk to them in person because, teachers can say one thing by the computer, but when you're face to face, you can see their emotions. Or even if you call them on the phone and you talk to them, you can hear it in their voice. And you can say, I'm not asking, that hook me up, but, and, kind of say like in a joking way, I just want to know, can I actually get out of this class? And I've been working hard. My major is blah, 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 blah. And don't ever tell a professor, your class is the only one that's preventing me from X, Y, and Z. Teachers don't want to hear that. We don't want to know that we're the reason why you are not doing what you're supposed to do. So it's better if you just tell your professor, hey, I want to know, what do I need to make on the final exam and the quiz in order to pass this class? And can I go back and redo any homework problems? I know it's a shot, but can I do that? Yes, see if she, oh yes, yes, yes. See if she's able to meet with you. Yes, that's right, user 3117. I'm gonna tell you, teachers love to hear from those students, especially the ones that we know aren't doing well. But if you come to us, we're like, oh, thank God they actually came and asked me a question, even if it is at the last minute, because that still shows that you're trying. So you still want to ask your teachers, regardless. You can say it in a joking way. Yeah, and you know what? That's why. What? Tell me, Aaron. What is the percentage of your exams? Like, how much are they weighted? Are they weighted higher than anything else? Okay, yes, Shadula. Yeah, Instagram works too. I'm not on Instagram, but I'm glad you actually told me that you sent it, so I'll know to go back and check it. Okay, so I'll check you out on Instagram. Yes, that works too. You're welcome. So now I know several of you all still have some more questions really quickly. So is the person that asked about Henry's Law, are you still here? The person that asked about Henry's Law. And if you are, say yes, so I will know if I need to go ahead and go through this problem or give you some tips. Now, while that person is coming up, let me show you all this other thing too. And this was on the ICE chart because I know some of you all. Oh yeah, the ACS final exam. Have you gone to their website to get like an example or a copy? Um, I would even look at like the what's the other thing? I would go to their website or even go to the CLEP exam, CLEP, because all the exams are just pretty much chemistry is chemistry, and it just depends on how much your professors have emphasized certain things. But if you go to the ACS website, let me see if I can even pull them up. Um, let me do another share. Let me see. Um, Now I'm pulling up one. I don't know if it's gonna let me per se do anything, but let me see. So these are the things that you need to focus on right here. So, and as you can see right here, they're telling you what's on the exam, solutions and stoichiometry. So a good portion of your test, it's kind of like you're going to get like 5 questions per topic: oxidation and reduction, equilibrium, kinetics, thermo, bonding. But also because this is general chemistry too that you're taking, I would say refer to the latter parts of those questions right there. Refer to those. Um, yeah. Oh, and even though, let me see, let me find something else too. Um, because there are so many different practice exams. Yes, there are so many different practice exams that you can also get online. And I'm always looking for the free. You always want to get the free. So these are just some of the things that you would want to know for General Chem 2. Of course, chemical equilibrium, acids and base ionizations, acid-base theories, solubility, redox. Like I mean, and I know it is a ton of stuff. There's a ton of stuff. And I know that that's the department test that they tend to give. And so that's the drawback because it depends on what your teachers actually covered during their class versus what they're doing for y'all online. But I would see if there's any um, free practice exams online for General Chem 2. And then kind of take it from there. Let me see. I may have downloaded one. I'm gonna find out. Okay, this is the chemistry Olympiad, something similar to what you would probably go through. So here's one exam or one example. And even though there's a mixture of different levels on this test, this is still worth a shot right here. This is still worth a shot. So again, I just Googled free chemistry ACS exam. And then this is what I came up with. And some of these questions are from General Chem 1, but there are also some that are from General Chem 2 as well. Okay, guys. Well, I mean, it's 1 o'clock now. Oh, you're welcome, Aaron, and good luck. But, don't give up and don't stress. I mean, I don't want to say, even if you have to take the class over, like the worst thing that can happen is, yes, that is the case, that you would take the class over. But here's the but though. In most universities, the new grade or the new grade that you get, they'll replace that with the old grade. So it's like it never happened. And best believe I was there at one point where I had to repeat some of my chemistry classes because for one, my mind wasn't mentally prepared for some of the stuff that I was doing. And number two, I also know that certain teachers teach a certain way and students just can't grasp it and they just don't know how to make it better. So in your particular case, Aaron, I would most definitely say that you would want to reach out to your professor regardless. And you never know what may happen. You never know. Never know. Okay. Are there any other questions or concerns from anybody else before we get off today? Yes. And Aaron, like, I wouldn't go out my way but check what the office hours are. Because if your final exam is next week, she should still have open office hours this week, but check to see what her schedule is like today so that you don't, go out your way and then she's not even there. Oh, you're welcome, Aaron. You have a blessed day as well. And still tap in with me and let me know how it works. Okay. Okay, I got you. And good luck tomorrow. You do know your stuff. I mean, I'm not gonna lie, you do know your stuff because I've worked with you, so I know you do know what you're doing. It's just the way the questions are being asked. I know teachers make things over difficult. Hassan, you want to know how to memorize those polyatomic ions? I don't have access to my note cards, but this has stuff on it. But I've been saying all semester long, get y'all some note cards and do what I call note card chemistry, where you're just writing the formulas down on paper on your cards. And so maybe make some flashcards. On one side, you're going to write the polyatomic ion's name, and on the other side, you're going to write down the actual here's an example. Let me cover this up so y'all don't see this part. But so for instance, on this side, I would write down, like the name, sulfuric acid. And on the other side, I would write down what sulfuric acid's name is. So that way you're able to see them. Those are the things that it takes time to remember and put them in different categories. Put them in different categories. Like H2SO4, H2SO3. Put the ones with those charges in them. I mean, I know it's a lot. I do know. Okay, you take care, Aaron, and I will talk to you later. What, you were blocked? No, you shouldn't have been blocked. No. Matter of fact, I'll email you when we get off, so that way you will have my email. Yeah. No, you shouldn't be blocked. I didn't block you. No. All right, guys. You're welcome, Haha Slime, and you all take care. And I will see you guys later. I'll see you all tomorrow at 12:15. 12:15. All right, you're welcome, Aaron. You take care. All right, guys.